So the next topic we have to cover is a bit of geometry. So after all the stress and things with exams, hopefully this will be a little bit easier for you guys. This is the breakdown of kind of what we're going to be looking at. We're only going to spend 2-3 lessons on it because I think a lot of this is probably things you already know quite comfortably. The angle properties of intersection lines, so parallel line rules, the different types of triangles, quadrilaterals, the properties of the quadrilaterals as well, the interior and exterior angles of polygons, and that's pretty much it to cover, and then a few obviously more in-depth questions. So I'm just going to dash through as quickly as I can to get you onto some questions, the main rules that we're going to use today. So the types of triangles we see in questions. So just have a think in your head, pause the video and have a think if you can think of them. So you should have come up with the equilateral. Now let's just think about the properties there. Equilateral, it's in the name, 3 equal sides and therefore 3 equal angles. There are 180 degrees in a triangle, therefore the interior angle there is 60 degrees. All equilateral triangles are also similar, obviously. Isosceles, I sat on South Sea Common eating lovely egg sandwiches. That is a triangle with 2 sides are the same. Always keep an eye out for these because the properties do really regularly come up in questions. So those 2 sides are the same, and obviously do not forget that the base angles are the same as well. We have that used out already this year when we were doing circle theorems, remember. Scaling, so just one where none of the sides or the angles are the same. That's probably, that almost looks like an equilateral. Well done. And obviously it's not a particular type, but just keep an eye out for right angle triangles because they involve Pythagoras and they involved trigonometry. How about quadrilaterals? Pause and think of all the quadrilaterals you can think of. Okay, so we should have got things like obviously square and rectangle. Most of your basic ones. You should also come up with a kite, a parallelogram, and a trapezium. Those are the main ones, I would say. Obviously from parallelogram as well, you get a rhombus. And that is a parallelogram where all the sides, I've spelled that wrong, where all the sides are the same length. It is basically what you would call a diamond. However, never use diamond as an actual term in a maths exam. It is not technically the name of any shape. Okay, let's just think of some of the properties. I'm not going to talk about the properties of squares and rectangles. You should know them and be comfortable with them. The trapezium, we have got, obviously, the defining feature is it's got a pair of parallel sides here. There is something connecting this angle here and this angle here, which will come on a little bit later because obviously it involves the fact that these are parallel lines. The parallelogram down here, so we've got these are parallel sides, and then we're going to use double arrows for the other one. Keep an eye out for all that notation at all times. For a parallelogram, you should know that these opposite angles are the same. You may need to state that in a proof, so make sure you are thinking about how you would write these. So the opposite angles in a parallelogram are the same. These two are, of course, would be the same as well, and of course all 4 of them would add up to 360 degrees. And there's also going to be something connecting this angle and this angle, which we'll talk about in a minute. Finally, the kite. So these sides are the same length and these sides are the same length, and these 2 angles are the same. And again, there's not really anything connecting that one and that one so much. So it's the main thing that obviously these 2 are the same and these sides are all the same as well. So try and remember, we have done this before, well, if I had you, we have done this. Try and think of the 3 main rules for parallel lines or angles on parallel lines. So pause the video and see if you can have a think about what they are. You should be writing out and drawing out these diagrams. Right, so the rules are, first of all, let's do a nice and easy one. These 2 angles are the same, right? Those 2 angles are the same. Can you remember what they're called? All right, these would be called vertically opposite. And again, if you had an exam and you had to show you, well, you should show your method anyway, you should show your reasoning, but a lot of these you'll lose the marks if you don't. You would need to use that correct terminology. Vertically opposite angles are the same. To clarify why they're called vertically opposite, it is not because kind of the vertical up and down kind of thing you're used to. It is because they're on opposite sides of a vertex. If you remember that vocab, then you've got vertices are the corners, and these are opposite sides of a vertex. So by that reasoning, basically anytime you get a cross, like you've got another cross here, the opposite angles are the same. There's that one is the same as that one, and that one is the same as that one. But you do need that vertically opposite ingrained into your brain. So that's the first one. That doesn't actually just apply to parallel lines, that applies to any kind of cross that is going to apply as well. Okay, so the actual ones that apply specifically to parallel lines. This angle here is the same as this angle here. So we've got 2 parallel lines here, and if you remember, this is called a transversal, this line here. These 2 angles are the same, and the reason that we would have to give, these are called corresponding angles, and these are equal. The way I like to think of it is if I take this here and I could slide it up the transversal, it would go right on top of there and be exactly the same. Right, next one. Okay, so these 2 angles, these are also the same. Can you remember what they're called? These are called alternate angles, and these 2 are equal as well. So the way I like to use to remember this is they zigzag. So things that zigzag, they alternate from one to the other. So I read this almost as alternate rather than alternate. So once you've got kind of that zigzag shape here, those angles on either side of those corners will be the same. By the same reasoning, obviously this angle here will be the same as this angle here because it zigzags along that one. And finally, the last one, these 2 angles here, hopefully just by a visual inspection you can tell that they are not the same. These are called co-interior angles. They're co-interior, they share an inside, if you want to maybe think about it like that. They're co-interior, and these are not the same, but they do sum to 180 degrees. So all of these are the types of the types of skills you're going to have to show in a question. Quite often, probably more often than not, questions involving these are going to have quite a few angle rules in there that you're going to need to use and apply. You're going to have to keep writing your steps, like the circle theorems. You have to include the reasoning, and it's a case of kind of spotting when you can use them. You're not going to be able to jump straight to an answer probably for most of these. You're going to have to do it step by step and go, you know what, I can work out some of these angles. One application I will flag up comes from earlier. So here we've got a parallelogram, and we've got a trapezium. So we know, for example, on the parallelogram, we said that obviously the opposite interior angles are the same, which is very useful. But also we know that this angle here and this angle here equal 180 degrees because they are co-interior angles. If you imagine, if I extend these lines here, and I extend this one as well. All right, we've got a pair of parallel lines here and here. We've got a transversal here, so these are co-interior angles. Similarly down here, if I think about extending this line here and here, I've got a transversal and a pair of parallel lines, so I know those two similarly are co-interior, and therefore they sum to 180 degrees. And those are kind of features that people do tend to forget about. So here's an example question. Have a go at it yourself first of all. Okay, so I straight away do not know how to work this out, so I'm going to do it step by step. So I know I can work these out because they're an area of, it's a triangle, and it's an isosceles triangle, and I've got one of the angles. So I know you'd automatically do this, but I'm stating every fact that I'm using. So 180 degrees minus 100 degrees equals 80 degrees, because angles in a triangle equal 180 degrees. And that 80 degrees divided by 2 is 40 degrees, because isosceles base angles are the same. So I at least know that's 40 degrees. I also can see a couple of parallel lines in there, so I'm going to see if I can use them. I can, because I know I've got kind of this alternating shape, or this Z shape, so I therefore know that is going to be 40 degrees as well, because these are alternate angles, and alternate angles are equal, so I know that's 40 degrees. So I'm starting to piece together all the angles in this question, which is going to make my life easier. Well, I can spot this straight line here, so I can use that to find this angle here, because I'm going to do 180 minus 140 degrees equals 40 degrees, because a straight line equals 180 degrees, so that's that reason. So I now know that that has to be 50 degrees, because a right angle equals 90 degrees. And I did 90, take 40 to do that. Okay, so lots of different rules I've had to use there to slowly piece together and get to my point. I didn't know what to do in that first, so I didn't even know if that was going to work, but I kind of just started piecing together bits I did know and eventually got to an answer. Please note, this is not just the one way to do this, and quite often you'll have questions where you'll have alternative methods available to you. For example, once I knew they were 40, if I look here, I've got these parallel lines, and I can use this transversal here to say that this here is 40 degrees as well, because it's corresponding, and I can get 50 from that instead. So I've actually skipped a step, and it's a quicker method. I didn't spot that straight away, but it's a completely valid method as well. You'll notice there's a 4-mark question. I'm not going to be able to do it in one step. I should know straight away, even from looking at that, that it's going to take me a few steps to get there.